Hello, and welcome back to Shiksha Costa. Today we're going to be reviewing the units C2, which is how to apply the sine and cosine law in acute triangles. The first thing that we learn in this unit is that in a triangle, in a right triangle especially, depending on which angle you choose, you can find out the value of the three primary trig ratios. The first one is called sine. And that ratio is between the side that is opposite that angle that you chose and divided by the hypotenuse of your right triangle. The second one is called cosine, and that is the ratio of the side that is adjacent to the angle that you chose, the side that is right beside it, divided by the hypotenuse. And the final one is called tangent, and that is the ratio of the side that is opposite the angle divided by the side that is adjacent to it. In other words, here are your three equations, and we can take the first letter of each of these parts here that I've got highlighted and put that all together to make a mnemonic that is pretty easy to remember. It's called SOHCAHTOA. SOH stands for sine of some angle is equal to the length of the opposite side divided by the hypotenuse. Cosine, or Ka, stands for cosine of some angle is equal to the adjacent side divided by the hypotenuse. And TOA stands for TOA, tan of some angle is equal to the opposite side divided by the adjacent side. If you ever want to solve a right triangle, you just need to find out which two side lengths you are comparing, and then use SOHCAHTOA to choose an equation and then solve for your unknown variable. If you already have the ratio, or if you have two side lengths already and you want to find out what is the angle, you can actually use something called the inverse function. And those look like this. They look like the ratios themselves, and they have a little inverse sign up top. And plugging in the ratio here would actually give you the angle in degrees. These are usually, you can find these on your calculator by using the second function or using the shift button and then pressing the ratio itself to get the inverse. From there, we moved on to the sine and cosine laws. The sine law is given to you here, and there's two versions of it. One of them which has the side lengths in the numerator, and one of them which has the angle in the numerator. Remember that the same letter is shared by opposite angles and side lengths. So this side length is opposite angle A. You can use the sine law when you have a pair, when you have an angle and its opposite side length. So now you have everything on one side of the equal sign, and you also need one more angle or one more side. So you need one of these, right? So if you have an angle, then you would use this version of the sine law because the only thing that you wouldn't know is the side length. If you have another side length, then you would use this version of the sine law because you would just need to isolate the angle measure. So if this was your triangle and you had a pair, that would be your clue that you need to use the sine law. The cosine law is used when you have three sides or when you have two sides and a contained angle. So again, if this is a triangle, and notice the side lengths opposite each other have the same letter, and here it is for C. Now, if you have three sides, it's pretty easy to know. But what if you have two? What does two sides and a contained angle mean? Well, it kind of looks something like this. Here are two side lengths, A and C, and I have the angle in between, B. So if I have these three, then I can solve and I can figure out what these three are. I can find out what this side length is by using this version of the cosine law. And if I have three sides, I can find out what any angle is by using this version. And the important thing to remember about using this version, about using either version, is whatever angle or side you choose over here, the opposite angle or side needs to be here, or in here. So this is capital C, that's the angle. The opposite side needs to be chosen for this variable right here. The other two sides don't really matter. Same with here. It doesn't matter which sides you choose for these two, as long as whatever side you have over here, its opposite angle must go here. Finally, we learned where we can use trigonometry in real life. Especially, we can use it to measure distances that we can't physically reach. Surveyors and cartographers use it in this way to find the width of rivers, roads, or canyons. Carpenters might use it to measure distances for furniture or buildings that they're building buildings that they're building. Maybe I could have worded that a little bit better. An important thing to note here are two terms, an angle of elevation and an angle of depression. Both of these are an angle between a horizontal line and another line. With an angle of elevation, that second line is pointed upwards, sort of like this. This is an angle of elevation. This is a horizontal line. And if you look up, now you've created an angle of elevation between those two lines. An angle of depression, likewise, is an angle between that horizontal line and a line that is pointed downwards. So if you're looking down from a horizontal line, if you're looking straight and then you turn your eyes downwards, you've created a little angle of depression. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.